Hello students, today we are with the chapter current electricity and the important problems related to it. So before getting on to this chapter, let's discuss the basics about current electricity. Okay, so I hope all are aware of Ohm's law. As you know, Ohm's law states that the voltage is equal to the product of current and resistance R. Okay, and another thing which you should be aware of is the series and parallel combination of resistors. Okay, the series combination means one resistor is connected after the other. Okay, so here we calculate the total resistance as the sum of the individual resistance. S is equal to the sum of individual resistances. Okay, so R1 plus R2 plus R3. This will be the case of a series resistor. Okay, also you should know that in a series resistor, the current through all of the resistance is same. Okay, it is the same current which flows through all of these resistors. Okay, so in a series connection, the current is same, but the voltage across different resistors is different. Okay, let's say the voltage across R1 is V1 and the voltage across R2 is V2 and the voltage across R3 is V3. So the net voltage V is equal to V1 plus V2 plus V3. Okay, you should be knowing this, that in a series combination of resistance, the current is the same while voltage is different. Voltage across different resistors are different. Okay, now moving on to parallel combination of resistances. So what parallel combinations is that the resistance are connected one above the other. Okay, this is termed as a parallel resistance, R1 and R2. So here the effective resistance is calculated by 1 by Rp is equal to 1 by R1 plus 1 divided by R2. Okay, and so on. Howsoever resistance are given in the question. Okay, this is the case of a parallel combination of resistance. Here the current is not the same, but the voltage is the same. Okay, the voltage across this resistor R1 and R2 are the same. It is the same voltage that appears across both the resistors. Okay, so it is the same voltage V, but the current through here is I1 and I2. Okay, so the current in the main circuit or the current in the total circuit will be the sum of the individual currents. That is, the current in the circuit will be given by this I1 plus I2, and the voltage across each of the resistors is the same, but the current splits into two. R1 current passes through I1 current passes through resistance R1 and I2 current passes through the resistor R2. Finally, the total and effective current in the circuit is given by I1 plus I2. This forms the basics of the problems related to current electricity. So now we can move on discussing the problems and their solutions. Okay. So the first question is the cell of EMF 1.5 volt. Okay, the cell of a given EMF is 1.5 volt and the internal resistance of the cell is 1 ohm. So when the internal resistance is also mentioned in the question, you need to consider that too. Okay, connected to two resistors 4 ohm and 20 ohm in series as shown in the figure. Calculate the current in the resistance, potential difference across 4 ohm, the voltage drop and the potential difference across the cell. This is the most important question where you will cover all the basics. Okay, all the questions related to every formulas. Okay, you will calculate the current, the potential difference, the voltage drop, the potential difference across the cell, everything in detail. Okay, here you should be noticing that the 4 ohm resistor and the 20 ohm resistors are in series. Okay, and you should also consider the internal resistance of the given circuit. Okay, so let's move on to it. Here, given that the EMF of the cell is 1.5 volt and internal resistance is 1. Okay, so this I have mentioned here. The EMF is 1.5 volt and the internal resistance is 1 ohm. Since I have already mentioned that this 20 and 4 are the series connection, then the series resistance RS will be the sum of the two, which is 20 plus 4, which is 24. Okay, so while considering the effective resistance R of the circuit, you need to consider this internal resistance also. So the total resistance will be the series resistance plus the internal resistance small r. Okay, that is 24 plus 1 is 25 ohm. That forms a resistance. Now we need to calculate the current in the circuit. The current in the circuit is given by the formula EMF divided by total resistance. Okay, here the EMF is 1.5 and the resistance, total resistance is 25. On solving, you will get 0.06 ampere. Okay, so the next question, which is the potential difference across a 4 ohm resistor. we know that the potential difference is given by V is equal to IR. The current passing through 4 ohm resistor is the current in the circuit, right? Okay, so the current will be 0.06 and the resistance of the 4 ohm resistor is 4. So on multiplying, you will get 0.24 volt. Okay, now we move on to calculate the voltage drop. The voltage drop is given by small v is equal to the current in the circuit multiplied by the internal resistance. Okay, while calculating the voltage drop, you need to consider only the internal resistance and not the total resistance. Okay, you should consider only the internal resistance while calculating the voltage drop. So here the current is 0.06 ampere and the internal resistance is 1. So on multiplying, the voltage drop is found to be 0.06 volt. Okay, now we need to know calculate the potential difference across a cell. Okay, potential difference across a cell. You need to calculate the potential difference across a cell. So we know that the EMF, this is an important question, formula. EMF is equal to the terminal voltage V plus the voltage drop small v. Okay, so this is an empirical formula you should be knowing of. The EMF of the cell is given by the terminal voltage V plus the voltage drop small v. Okay, so now here we are asked to calculate the potential difference across a cell. Okay, so we can calculate the potential difference is nothing but the terminal voltage. Okay, so the terminal voltage is given by EMF minus voltage drop. Okay, so in the question it is mentioned that the EMF of the cell is 1.5 minus the voltage drop we have previously calculated, which is 0.06. On subtracting, it is found to be 1.44 volt. Okay, always you should be knowing that the EMF is always greater than the terminal voltage. Okay, EMF is always greater than terminal voltage. EMF is greater than terminal voltage. Okay, and the terminal voltage will be less than the EMF due to the voltage drop across the electrolyte. Okay, so EMF will always be greater than the terminal voltage, and this particular equation you need to keep in mind. This particular equation, which is the EMF of the cell is equal to terminal voltage plus voltage drop, is a very important question, and this formula has appeared several times in the past ICSE question papers as well as for the MCQs also. Okay, so this equation you need to keep in mind, and while calculating the voltage drop, you need to consider only the internal resistance of the cell. Okay, and not the effective total resistance. I hope this question is clear to everyone. Let's move on to the next question. Here it's given that the figure shows an ammeter. In the given figure, it shows an ammeter A, and the ammeter reads 0.3 ampere. Okay, the ammeter reads 0.3 ampere, and the voltage or the voltage of the cell or the EMF is given by 6 volt. Okay, it is given by 6 volt, and now we need to calculate the total resistance of the circuit, the value of the unknown resistance R, and the current passing through the resistance R. Okay, the informations are provided, and we need to calculate the following questions. Okay, so let's move on. Here you should understand that the 0.3 is a current in the entire circuit. Okay, so the current is given by the current I is given as 0.3 ampere. The current in the entire circuit is given to be 0.3 ampere. Okay, the current in the entire circuit is given to be 0.3 ampere, and the voltage is given voltage is equal to 6 volt. Okay, so now you need to calculate the value of the resistance R. We know that voltage is equal to 6, current is equal to 0.3, and resistance is given by the formula R is equal to voltage by current, that is 6 divided by the 0.3, which is 20 ohm. That means the effective resistance of the circuit, the effective resistance of the given circuit is 20 ohm. Okay, the effective resistance of the circuit is 20 ohm. So first we have calculated the total resistance of the circuit, and now we move on to calculate the value of the resistance R. Since there is nothing mentioned about the internal resistance of the cell, we don't have to consider anything of such. Okay, moreover, nothing is said about the resistance of the ammeter, so we don't have to consider the resistance offered by the ammeter as well as the internal resistance of the cell. Only thing you need to consider is the value of this resistance, unknown resistance R, and 20. Okay, 60. Nothing is told about the internal resistance of the cell and the resistance offered by ammeter, so you don't have to consider them. Okay, now this 20 ohm, this effective 20 ohm will be contributed only by the parallel combination of this unknown resistance R and 60 ohm, because they form the parallel. Okay, so now we can apply the parallel equation. The equation for parallel connection. Okay, we know that 1 by Rp is equal to the unknown resistance 1 by R plus the known resistance 1 by 60. Okay, the effective resistance is contributed by the parallel connection, so Rp can be replaced with 20. 1 by 20 equals 1 by R plus 1 by 60. On solving, you will get R to be 30 ohm. Okay, so the unknown resistance R is found to be 30 ohm and the other resistance is given to be 60 ohm. Okay, so this together forms an effective resistance of 20 ohm to the given circuit. Okay, I hope it is clear now. Next is the most important and most confusing question. The current through resistance R. Okay, see, you should listen with great detail. Okay, here what happens is as the current flows, the current in the entire circuit is given to be 0.3 ampere, which is measured by this ammeter. So the current passes through the ammeter and reaches a point here. Okay, when the current, which is equal to 0.3 ampere, reaches this point, it has two paths. Okay, some of it gets splits and enter into the resistance R, which has now found to be 30 ohm, and some of the current split and enter to 60 ohm. Okay, we have already discussed the basic that for a parallel combination, the current need not be same. The current is not same, but there the potential or the voltage is same. Okay, so you need to understand that the voltage across is R resistor, R ohm resistor and 60 ohm resistor is the same, but the current through them is different. But on the whole, the current through R ohm resistor plus current through 60 ohm resistor gives you 0.3 ampere. Okay, all right. So let me consider that. Suppose I current pass through. Let me consider that I current, small I current pass through this R ohm resistor. Okay, the total current in the given circuit is 0.3. If I current pass through this R ohm resistor, then what will be the magnitude of current passing through 60 ohm? The total current is 0.3, right? The total current is 0.3. If I ampere passes through the resistance R, then what are we left with? It is 0.3 minus I, and the 0.3 minus I will pass through the resistor 60 ohm. So resistor of resistance 60 ohm. Since the voltage across the parallel connection same, we can say that the voltage across this R ohm resistor is equal to voltage across 60 ohm resistor, and we can try solving them. Okay, so here clearly I have indicated that. Okay, since the 0.3 ampere is the total current, here some of the current passes through 30 ohm and some of the current passes through 60 ohm. Let's say that the current passing through 30 ohm is I. Okay, so there the voltage drop is equal to 30 into I. Okay, and the remaining current is 0.3 minus I. This current passed to 60 ohm resistor. So the voltage drop across the 60 ohm resistor is 60 into 0.3 minus I. Since they form the parallel combination, we can say that the voltage drop across both of them are the same. On cancelling, we get I equal to 2 into 0.3 minus I. Okay, I is equal to 2 into 0.3 minus I. So let's solve it. I is equal to 2 into 0.3 minus I. Okay, so I is equal to, opening the bracket, we get it is 0.6 minus 2i. Okay, so on bringing this minus 2i to the left side, we get 3i is equal to 0.6. So I is equal to 0.6 divided by 3, which is equal to 0.2 ampere. Okay, that means the current which is passing through this 30 ohm resistor will be 0.2 ampere. The 30 ohm resistor was our unknown resistance, so the current passing through our unknown resistance is 0.2 ampere. So you can directly imagine what will be the magnitude of current passing through the 60 ohm resistor. The current passing through 60 ohm resistor will be 0.3 minus 0.2, which is equal to 0.1 ampere. Okay, all you need to consider or remember is that in a parallel combination of resistor, the voltage drop across each of the resistor will be the same, but the current will be different, and the current through each of the resistor when added up will end up giving the total current in the circuit. Okay, I hope this is clear. We move on to the next problem. Here I have displayed you the solving of this. I is equal to 0.6 into 2i. On solving, I can be found to be 0.2 ampere, which is the current passing through unknown resistance. R is equal to 30 ohm. The current passing through 30 ohm is nothing but which is 0.2 ampere. Okay, the next one. Three resistors are connected to a 6-volt battery as shown in the circuit. Calculate the equivalent resistance of the circuit, the total current in the circuit, and the potential difference across a 7.2 ohm resistor. Okay, clearly this two forms a parallel combination of resistance and this is series. So we can calculate the series. First we can calculate the parallel combination of resistance and then add up with the series. So clearly the 8 and 12 form the parallel combination of resistance. So 1 by Rp is equal to 1 by Rp is equal to 1 by 8 plus 1 by 12. Upon solving we get Rp is equal to 4.8 ohm. Okay, so this 4.8 ohm and the 7.2 ohm are in series connection, so we can add up the series. Rs is equal to 4.8 plus 7.2, which is nothing but 12 ohm. Okay, so the effective resistance R in the circuit is 12 ohm. The total resistance R is equal to 12 ohm. Okay, and now we need to calculate the current in the total current in the circuit. Current is given by the formula I is equal to voltage divided by resistance, which is equal to 6 divided by 12, which is 0.5 ampere. So the total current in the circuit is 0.5 ampere. And the next one is we need to calculate the potential difference across the 7.2 ohm resistor. We know that the current passing through the 7.2 ohm resistance is nothing but 0.5 ampere. So voltage drop is given by V is equal to, not voltage drop, the potential difference V is given by V is equal to IR. So we can calculate current is equal to 0.5 and the resistance is nothing but 7.2. So it will be nothing but which is equal to 3.6 volt.